Hello everyone, in this class we are going to start a new topic in C programming language, that is storage class used in C programming language. Now, what is storage class and why storage class is required in C programming language? Look, when we write any program in C programming language, at that time that program contains only two components. One is instruction and other one is data. Instructions means which operation will be performed by the program, and what is data? Data defines on which constant value those particular operations will be performed. So these are the two main components of any particular program. Now, among these two components, instruction and data are the main component. Why? Because data is the component on which we want to perform the task. Clear? And those data are stored in main memory. In generally, data are stored in main memory but in multiple sections like data section, stack section, heap section. These three sections are used to store data. Now, whenever we declare any variable in C programming, it can be a local variable or it can be a global variable. If we declare the variable as global, at that time the memory is allocated for the variable from data section and initialized with 0. But when we declare any variable as local, at that time memory is allocated for the variable from stack section and initialized with garbage value if we did not specify any initial value in the declarative statement. Now, there is some limitations with this approach, whatever we learned till now. First of all, we need to know what are those limitations, and after that we will learn how we can solve all those limitations Clear? Now, the first limitation is in C programming we can use any number of variables any number of times. We can declare any number of variables and we can also use those variables at any number of times. But there is one limitation. What is that? That is, whatever variable we use, we need to declare that variable before use of that particular variable. That is one limitation. That means limitation 1 is declare before use. Now, how this makes a problem? Look, let's say we have declared a global variable integer x, and then we have main function, and then within this main function we declared int z equals to x plus y, and the variable y defined after the variable y is declared after the main function. Now look, this is global variable, this is again global variable, and this is a local variable. Now look, as x and y both are global variables, that means we can use those variables in any part of our program. But look, in this case where we are using these global variables x and y inside main function, but the variable x is declared before its use and the variable y is declared after its use. Here we are using this variable but declared after its use. So even though it is a global variable, then also it will create a problem. We need to declare the variable before its use. So this is one problem. Clear? Now coming to the next problem. What is the next problem? Next problem is whenever we declare any variable, memory is allocated from main memory, and we already know the program will execute by the system, and memory and the data are stored in the main memory. But the working speed of CPU and main memory is not same. CPU works much faster than the main memory, that is our RAM. So there is a bottleneck. Whatever speed CPU has, it is not able to work at its peak of speed only because of RAM. Clear? Because RAM has very low speed than the main memory. So how we can solve this particular problem? Clear? Look, CPU will execute the program and we have main memory. So in main memory we are storing the data on which CPU will work. Now whenever CPU work any particular task, at that time CPU need to read the data from main memory and then perform its task specified in any instruction, and then again CPU need to store the data in the main memory. That means after operation the result is also need to stored in main memory. That means for any operation the bottleneck in speed is only because of this main memory, because the working speed of main memory is much lower than the working speed of CPU. So how we can resolve this problem? Look, inside CPU also we have memory. What are those memory? Those memories are called register. And the working speed of CPU and register are almost same. Clear? Almost same. So if we are able to allocate memory for variables from these registers, at that time this particular bottleneck of working speed will resolve. We can resolve by using registers to allocate memory for the variables if it is possible. Clear? So this is another problem. So second problem is speed mismatch between CPU and RAM. So that is our second problem. Now coming to the third problem. What is that third problem? Look, let's say we have a function and in this function we have integer x equal to 2 and then we are doing x plus plus. Now here we called the function fun and then fun 2 times. Now how system will evaluate this particular code segment? Look, first of all system will allocate memory for main function. This is our main function. Now from this main function first instruction is fun. That means we are calling the fun function here. Now what system will do? System will the control of program execution come out from the main function and enter into the fun function. That means from here control switch to the fun function and allocate memory for fun function. Now what happened? Inside the fun function we are declaring a variable x. That means here a memory block will create with identifier x and initialized with 2. Now after next instruction is x plus plus. That means the value of x will be increased. Now what happened? The closing we encountered with the closing brace. That means control come out from this instruction, and whenever control come out from the fun function, at that time it will come back to the main function from where the fun function get called, and this particular memory block will deallocated. That means no longer memory is exist for the fun function that already executed by the system. Now coming to the main function, now we are again come back into the main function. Now inside main function, what is the next instruction? Next instruction is again fun. That means we are again called the function fun from main function. Now again control come out from main function and enter inside the fun function. Now we are in fun function, and inside the fun function again we allocate a memory block for the variable x and initialized with 2, increment the value of x. Now the value of x is 3. Now come out from the fun function. Now again we are coming out from the fun function, and then this memory is deallocated. Now this is the normal basic scenario how system work with any function. Now what is the problem in this case? Look, there is some scenario when we may need to get the previous execution status of a particular function. What does it mean? That means, look, when we execute function fun for the first time, at that time system will allocate memory for the fun function, and then all the variables declared inside fun function, memory is allocated for those variables from this fun function. And when come out from this function, system deallocate all the memory. That means all the variables that already used in this execution are already removed from the memory. Now no longer any value is available in fun function. But what happens if we need those value, some of those value or all of those value in the next execution of this particular function itself? Again we need. So what at that time what we will get? Look, in this case, after execution of this particular function, the value of x becomes 3. But when we execute the fun function for the next time, at that time also the variable x is initialized with 2 and update to 3. But here in this execution the updated value is 3. What happened if we need the updated value of x in this execution also, in this instance of function execution also? In current scenario or in basic scenario, we never get back the previous status value or all the updation whatever we did in a particular function definition. Whenever we come out from that particular function, we will lose all the updation that we made in this particular def function. That means when we update any particular value here, and when we come out from this particular function, all the informations we used in this particular function instance all we lost. We will never get back any of those values. And then when we execute the function for the second time, at that time the function will restart. For the function will reallocate memory for all of its variables and start again execution of the same things repeatedly. Clear? Now, so that means we lost the all the information whatever we used in this function call. We will not get back any of the values in the second execution of the same function, even though it is required for us. We are not able to acquire any of the previous value from the previous execution instance. So this is another problem that we get in case of function. Clear? So limitation number 3 is, so we lose all information for any instance of function execution after come out from the function. Look, so these are the 3 problems that we face in normal variables, in normal scenario of variable declaration. Now, to solve each of these particular problems, they introduced with a new concept called storage class. Clear? So storage class is a concept using which we can resolve all of these 3 problems in C programming. Now that means storage class is a collection of keywords that will used to change the behavior of variables. So what is storage class? Storage class is a set of keywords those we can use to change the basic behavior of variables. So what are those keywords and how many keywords are there in storage class? There are 4 keywords they defined as storage class. What are those keywords? The first keyword is auto, second one is extern, the third one is register, and the fourth one is static. Now in this class we will learn first 3 storage class, and in the next class we will learn the static storage class. So what is the first one? Auto. Look, whatever we work with till now, in any of those variable declaration we never use any storage class, and all of those used the default storage class, and among these 4 storage class, auto is the default storage class. This one, auto, is the default storage class for any variable. That means till now, as we did not use any storage class for any variable declaration, that means system internally use this auto as storage class. That means what? Look, when we use integer x, at that time system internally consider it as auto int x. That means till now whatever we know about a variable, all those informations are come under this auto storage class. So there is nothing new to learn in auto storage class. Clear? So auto is already done. Now the next part, what is extern? Extern storage class. Look, the syntax of use of extern is extern, then data type, then variable name. This is the syntax of use of extern storage class. Now look, when we use extern storage class, at that time it is not a declarative statement. It is not anymore a declarative statement. Whenever we use extern storage class with any declarative statement, at that time it will become a non-declarative statement. That means it is no longer a declarative statement. Now, what does it mean by no longer a declarative statement? That means memory will not allocate for such variable, such extern type variable. No, memory will allocate for any extern type variable. Now, then how we can store data using this variable, as there is no memory is allocated for this particular variable. And what is the purpose of use of this extern keyword? Look, we already faced some problem that we need to declare before use, and we already saw a scenario where we faced problem. Now let's consider the scenario main. Inside main we are using int y equal to x, and we declare this variable x after main function, that means integer x equal to 20. Now what happened in this particular scenario? We are using before declaration. Here it is declared, x variable is declared, and here we are using the variable x. So in this case it will give us an error that x is undefined even though we already declared the variable x. So how to resolve this particular problem? To resolve this particular problem we can use the extern keyword. Now how we can use the extern keyword? Look, before use of this variable, the variable x, we can use the extern keyword as extern int x, and then we can use the variable int y equal to x. Now what happened? What does this instruction do here? Look, the extern keyword is used to tell the system that we already declared the variable in the program, but it may not declared before its use. Please kindly go through the whole program and check and find out where the variable is declared. Clear? That means it is just an information for the system that we already declared the variable in our program, but may not we declare the variable before its use. Please kindly go through the whole program and find out where we declare the variable x. Clear? That is the use of the variable, use of the storage class extern. Clear? So as we already declared the variable integer x here, that means here memory is allocated for the variable x itself. So we don't need to reallocate memory for the same variable as we already allocated memory for the variable. Clear? So that is the use of extern keyword, and by using extern keyword or by using extern storage class we can resolve this particular problem. Clear? So whenever we need to use any variable that is declared somewhere in the program but we are not sure that the variable is declared before its use, at that time we will take the help of extern keyword. Clear? So that is the use of extern keyword. Hope you understood the concept of extern and when we need to use the keyword, the storage class extern. Now coming to the next storage class. The next storage class is register. So the syntax of storage class register is register register then data type then variable. So the use of register storage class is, look, if we declare variable as integer x or auto int x, at that time from where memory will allocate from RAM or main memory. And due to this reason, as memory is allocated from main memory, due to this it becomes a bottleneck for our execution speed of the program. So we can solve this particular bottleneck by allocating memory for the variable from CPU register itself. To allocate memory from register for any particular variable, we need to use the storage class register in the variable declarative statement. So to allocate memory from register, not from the main memory, we need to use this particular storage class register. That means if we declare register int x, at that time the memory allocated for this variable x is from register, not from the main memory. But here is one problem. What is that problem? The problem is the number of register in any particular system is very less, very less. So there is a possibility that when we use this particular storage class register, at that time all the registers available in that particular system are in use. That means CPU are already using all of the available register. At that time what will happen? So because of that limitation in the number of registers available in any particular system, the inventor of C programming make this particular storage class register as request, not as command. So this storage class request is not a command. This one is a request. It is a request. What does it means? What does it means? That means command means system have to execute the instruction as it is in any scenario, but request means it is request and system is not bound to execute the whole instruction as it is given in the program. Clear? Now in the instruction when the storage class register is used, at that time system takes this particular instruction as request and search first for the register, check whether any register is available or not. If that much registers are available, at that time system will allocate memory for the variable from register. Clear? And if it is not available, at that time what system will do? At that time this particular instruction will become or will behave as normal instruction, that is auto int x, and system internally decide whether it will execute as register or it will execute as auto. If register are available at that particular time, when system encounter this particular instruction, at that time memory will allocated from register, and if all the registers are already in use, at that time system convert this particular storage class from register to auto and allocate memory from main memory itself as our previous cases. Clear? Now so there is no guarantee that we can resolve this particular problem. Why? Because the number of register is limited in any particular system. Due to that reason, as the number of registers is limited in any particular system, this particular storage class register is designed as a request, not as a command. Clear? So when we use register storage class while declaring any variable, at that time if memory is allocated from register, then execution of the speed will increase, and if memory is allocated from main memory, at that time the program execution time will remain same. So when we use this particular register storage class at the time of variable declaration, at that time if memory is allocated from register, at that time the execution speed of the program will increase. But if memory is not allocated from register, it is allocated from main memory, at that time execution speed will remain same. Clear? So that is not guaranteed that every time when we use register storage class it will increase the program execution speed. Clear? Now one more problem with register storage class. If the memory is allocated from register, at that time we can't take input for such variables. Why? Because the registers don't have any address. When we allocate a variable with register storage class and memory is allocated from register, at that time we are not allowed to take in address of operator with those particular variables, and due to this reason we can't use those particular variables in scanf instruction. That means we are not able to take input directly for any variable that we declared as register type variable. So what is the scenario? Let's consider an example. Let's say we declare a variable register int x and memory is allocated from register. That means in CPU register memory is allocated. Now if you want to take input scanf %d, as we already know, when we take input using scanf, at that time we need to specify the address where we want to store the input data. That means here we need to use the address of operator of x. Now as we already declared the variable x as register, and it is not guaranteed the memory for this particular variable will allocate from register only. It may be allocated from main memory, but we don't know from where system will allocate memory for this particular variable. If the memory is allocated from main memory, at that time this particular instruction will execute. But if the memory is allocated from register, at that time it will give us an error. That means there is an uncertainty whether the memory is allocated from register or not, and depending on that the execution of the program will behave. And due to that reason, whenever we use this register storage class to declare any variable, at that time we in generally not use those variables to take input directly, like this particular instruction. Clear? So as here we use address of operator with x, and this address of operator will return the address of the base address of the memory block that will identified by the variable x. Now if x memory block is allocated for x from register, at that time those register is not going to have any address. At that time this operator will become invalid for register, and due to that, if memory is allocated from register, system will give us an error. Clear? So because this is one more problem with the use of register. So to solve the second problem, that is speed mismatch between CPU and RAM, we can use the storage class register, but it is not guaranteed that it will solve the problem or it will increase the program execution speed. It is not guaranteed. It depends on the availability of register at that particular moment of time when system encounter this particular instruction. At that time, if register is available, system will allocate memory for register for this variable x from register. If register is not available, at that time system will allocate memory for this variable x from main memory itself. So even though register storage class is available for us, it is not guaranteed that it will solve this particular problem of speed mismatch. And the main point is register storage class is not a command, it is a request. Clear? So that's it for today. Hope you understood the whole concept of auto, extern and register storage class. In our next class we will continue with the static storage class, and that storage class will resolve this particular third problem. Clear? So that's it for today. See you soon in our next class. Thank you.